All right, this is our Simon Says game project. For this project, we used an Arduino Uno with a breadboard and a bunch of lights to signal the sequence of events that the user is supposed to follow. We have 4 of us in this group. We've got myself, Braden Lemke. We got Andrew Cox, Caleb Justice, and Alex Martinez Rincon. So we programmed 3 different games into this Arduino. The first game is your classic Simon Says game, where you're going to see we have 1 light flash to start the sequence. You'll see in a second here. So here's our menu. We start the game. You can see the green flash. That's the start of our sequence. And then after each round, you could say, a new light flash is added to the sequence. So we're already on to 3 different. This will add a 4th. You have to tap on the buttons that correspond to the given lights that flash. The fun part about this game is it really tests your memory. It's fun to pass around with friends and see who can remember the most sequences. You can see when you lose, all the lights flash, signify that you lost, and then it will replay the sequence that you messed up. Here's the second game.
So on the second game, we added pretty much just a second. We introduced 2 new flashes for each sequence. This with the hopes of, I guess, increasing the difficulty, just a stepping stone, I guess, into the next level. Yeah. And of course, it follows pretty much the same pattern as before. Yeah, you just enter, it gives you the 2 flashes per sequence, and then, yeah, of course, you have to guess through the buttons on the board.
Here's the third game.
So this is the third game. This is the speed game that we added. You select it from the menu, just like the other first 2 games. This one is a good way to also improve your memory and kind of see where you're at, while also having a little bit more fun, trying to be fast with it. This one also can be really competitive. It's fun to pass around with your friends so you can get the better score. And then it follows the same light sequence once you lose if the game is over. So we ran into a few problems when trying to design and create this game. One of them were that we all were remote, so we all had to create our own rather than work on one separately or individually together, which kind of in the end benefited us because we all had our own collective knowledge and ran into our own problems that we could then share with each other, and definitely paved the way to speed up the process a little bit. A challenge that I ran into specifically, I tried adding an IR receiver to my game so you can control it remotely. And the IR had problems. I had to use an external library. The controller has to be at the perfect angle to the receiver, or it picks up the wrong signal and will recognize it as a different button being pressed.
Yeah, on another end, I know that we were initially aiming to have this working just completely, the board itself, and as far as the input from the user to do it like pretty much remotely through Wi-Fi, either through an app or through a website or something like that. Initially on my end, and I think that's pretty much on all of our ends, we struggled a lot with the Wi-Fi configurations. It was an idea that we initially were very excited about, but it just was not. We were not able to bring it into fruition. At the end, I think the closest that we got on my end was we were able to get kind of a website running on that, but it was just only working through the URL buttons and whatnot to turn on the lights through the page, not working correctly. So we ended up just desisting from that idea and instead taking the approach on adding this more difficulty into the games, beyond the regular and classic Simon Says game.
Yeah, one of the main issues that I ran into was I'm pretty sure I ended up buying a Bluetooth module that was just totally fake. Trying to get it hooked up to an app. I brought my Arduino project to a coworker of mine who has an electrical engineering degree and said that what I had set up should have worked. And so that was heartbreaking to know that like it could have worked if I had bought the right module, but by then it was too late. And so we stuck with the classic, just physical buttons. You can see here, Andrew's setting up the whole board from scratch. You can see we got the 4 buttons all in a row to line up with the lights. Something that we learned was how finicky these breadboards can be and how precise you have to be on setting up these different connections. I had never built an Arduino project before this, and so I learned a lot about connecting power to certain parts of the board and even just connecting different wires to ground and the importance of that. You can see there's the board right there. Got our different inputs. He's going to start connecting everything to.
And to give you an idea of what the breadboard's doing here with the pins and jumper wires and all that, basically we feed 2 separate powers into these buttons, since the buttons will have 2 sides, right, that connect straight across. So one of those is just a constant power source that when we press the button it goes through to the LEDs, and the other is the power source that goes from the pins to the LEDs. So at one point we will set the LEDs to display the sequence, for example, and it will take the power through the pins, and then when it's time for the users to do the input, you can see we've got it hooked up so that constant power going in, that's the orange cable there, connected to the blue cable, which is our 5 volts. That is how we'll know the player's input. And then that also connects up back to the pins. So it's a pretty cool process how the whole thing's laid out. You know, we've got it set so at one point you have the display going out, and then at one point it's looking for user input. So to walk it through the beginning, we have our blue cable, which comes from our power. That connects into the plus side of the row at the where I'm plugging it in right now. That feeds into the orange cable, which feeds as a constant power source into the button. But the circuit's not complete. The power going through that button right there does not make it to the resistors and the red wires that feed into the LEDs, making the display. There's also power that comes from the pins, 3, 5, 7, and 9 in this case. That connects to the other side of the button, that left side of it, which is grounded by that resistor. And then that circuit's already complete. As soon as the lights want to go through from the pins, we want to display the pin information, that goes directly through as it's flashing right here. But the button circuit is only complete as soon as we push the button down, and that's how we can control whether we're making input or showing output. So here's our code here that actually explains a bit of what's going on. We set a wait time of 5,000 milliseconds. So we have 5 seconds to input our next button press on the Simon game. And we have a bunch of other variables we use to keep track of. For example, how long is the sequence here? What's the last button we pressed? Is the button pressed? Are we waiting for the user to input something? A couple of things here. And then we also determine our pins, which in this case we're using 3, 5, 7, 9. If you were to replicate this code, you would just need to change those pins to whichever ones you're using. So pretty cool how that's set up, and variables are used all across all of them. So we also have variables for our Simon game and our speed game. Here we just have a couple of functions that are going to display the lights. You see when we play the game, you know, they flash back and forth, or 2 pins light up at once, or they blink, all 4 of them at once. So each one of these functions does that sort of functionality for us. And we've also got one that writes to all pins. That's sort of a base function we use on all of them, where we can write to all 4 of the pins at one time. So I separated my code out to have, say all of the display functions are here, or we separated our code out more accurately. So here we can determine whether we're inputting information or outputting information, right? So either it's the player's turn or it's the Arduino's turn. Now this is the cool part. We have a basic loop, our basic loop that goes through. We can choose our game mode. You either press the first button, the second button, or the third button, and that will set a variable to our game mode here in the select game mode. So we press the first button, we're going to play the Simon game. Second button, we're going to play the Simon game with 2 lights going on. Third button's our speed game. Here's our code for the Simon game. First, we're going to display that we are, showing this sequence. Then the very first time through, we will show the pattern at the beginning, and then we're going to add something to the sequence. We're going to play the sequence, and then we're going to take the player's input to see if it matches. Here's our add next function. It's going to randomly generate one of the 4 pins to display, and then we add it to it. When we play through the sequence here, this will play before the player input and once the player loses. Here's our player input. We set it to input. We check to see if the time since the Arduino started minus the time since our last move is more than that 5 seconds, and if it is, we lose. In this code here I'm showing with my cursor, this is where we check to see that the right button's actually pressed. So we loop through all of them. Once a button's pressed, we say, okay, a button's pressed. Let's compare it to what we expect. If it is not what we expect, then we're going to say, okay, you've lost, and we're going to call this Simon lose function. And then at the end here, sort of an issue that happens is if you press the button, a pulse goes through, but it could count for like 10 presses, so that just resets it. Here's our Simon lose function. That just says, okay, you lost. And then we've got the same exact thing going on with our Simon hard game, where you have to press 2 buttons at once. Just that when we generate a sequence or add a new light to it, we generate 2 random numbers and we make sure that they don't match. So that's what this little do while does. It checks to see whether they're the same. We loop through it, we just display 2, just like we did with the first game, just showing 2 at once. Yep, and then we have 2 expected inputs, so we check for it twice. We have a first one, this giant if block, and then we have another if block that checks for the second one being pressed. And then we check to see that we've lifted off the buttons as well. There's our lose sequence. Just need to reset a few more things if we lose in the Simon game. Here's our speed game. We set it to output. Then it's going to show the little sequence that starts where it speeds up. We'll generate a random pin or a random light to show. And then we will give it to the player. The player will then input the correct pin or correct light, and then we will reduce the amount of time the player has next time. So there's our, we show it, we generate a random one, and then we play it. This speed variable here, we slowly speed it up by reducing how long it is. And we check for the correct button being pressed. And we play a lose sequence as soon as it's lost, and then we reduce the time there. And then this is at the very bottom here is our setup code. It just plays that intro every time you lose.
To wrap things up, I think some of the things I would have done differently is, first of all, ordered the Arduino and all the parts as soon as I found out about the project. Then we could get started sooner. The last thing is I'd like to try and make it look better, maybe print off or 3D print off some parts to try and put them inside. And yeah.